Which one of the following has maximum nucleophilicity? So, what is nucleophilicity? So, the power of a nucleophile. So, we know that nucleophile is negatively charged or it is electron rich. Nucleophiles can also be neutral or they can be negatively charged. So, a negatively charged nucleophile is more stronger than a neutral nucleophile. Now, what does this nucleophile do? It attacks an electron deficient center. Say some electron deficient center is there. This nucleophile uses its electron to bond with this. So, a nucleophile not only should be electron rich, but it should also be ready to donate its electrons to form a bond. Keeping all these things in mind, let's look at this option. First of all, if there is a negative charge, that will be always a stronger nucleophile as compared to something which is neutral. So we directly rule out option C because it is neutral. All other options you can see a negative charge. So now, out of all these nucleophiles, who will be able to donate its electron pair easily? Sulfur, here oxygen, and here fluorine. One thing we know about fluorine is that it is highly electronegative. An electronegative substance has a tendency to attract shared pair of electrons. It would find it very difficult to donate this electron pair so as to form a bond. Hence, this is a weak nucleophile. Coming to option A and B. In option B, I am seeing that oxygen is attached to benzene system. We should always think about resonance in such kind of system. So this minus charge, it comes here, it forms a double bond. This pi electron goes here, and therefore I can write the resonance structure like this: double bond O and then minus charge here. So as you see that in the resonance structure there is no negative charge on oxygen, and hence how will this oxygen donate electrons to form a bond? So therefore, if the negative charge or electron pair is involved in resonance, then again it becomes a weak nucleophile. So we have ruled out all our options. So the strong nucleophile here is option A, CH3S-. In option B, resonance is seen and hence this negative charge is not available. In option D, fluorine is electronegative, hence is a poor nucleophile, and in option C, it is not negatively charged, it's a neutral nucleophile, hence it is ruled out. So here answer is option A.